Welcome to the 19th of May COVID year for the Robot Builders Night Virtual for Dallas Personal Robotics Group. Tonight we're going to do the usual and just walk around the table and see what people have been up to, what they're planning to do. So if we would just let's get started, and I would ask Mr. Anderson on my screen, your top left. So this time, I think maybe I'll ask in the order of the clockwise on my screen, however that happens to be.
I've been called worse. Well, okay, what I've been working on this week, as you may remember in my last action-packed episode, I had decided that I wanted to upgrade the JBot outdoor robot. I wanted to move it from the MC68-332, my much beloved processor, to this new ARM processor. I've been working on the RCAT with the STM32F411, and it only had 3 UARTs and I needed 5.
Wow.
So I had thrown myself on the mercy of the group, and somebody actually did eventually point me to a software UART that's by from the STM library itself. If it had been a snake, it would have bit me. And so I sat down and I started working on the pinouts and the assignments for timers and USARTs and so forth for all that. But halfway through that prospect, Dave Ackley, who I see is here this evening, said, "Do you know about the STM32F446?" And I said, "No, I don't." So he sent me a link. It's a little more modern version than the 411RE, and it's a superset, so all of the software and everything I have will run on that. However, it includes 3 more hardware UARTs, and so I have a luxury of UARTs right now. So I ordered 3 of them, and they just came in the mail. I'll pull one out of its little packet. They look exactly like the other ones. I mean, the differences are, on the microscopic scale, on the chemical scale.
How much is one of these cost?
The main difference is that this one, where the other one says Nucleo F411, this one says F446.
David, how much does one of these cost?
I believe they were $9 a piece.
Oh.
So I got 3 of them because I always burn things up. Is anybody in this group in the last weekend, let's say, hooked up the touch display or something like that on and burned it right up? Okay.
Never wait for replacements.
Never order one of anything. That's what I've learned. It's just like when I'm working at the lathe. The hard part was setting up all the jigs and everything. So if I'm going to make one, I better make 3 because I've already done the hard part. So I have just set it up. I just got set it up today on my new breakout card, and started that process. And that leads me to 3 questions I have for this august assembled group. And the first question is, let me find it. I am running out of these. And these are, I'll pull some out so you can see what I'm talking about. These little connectors that I need to know what they're called so I can order more.
Are you talking about the ones that make you can make pin assemblies?
Yes. There's a little.
Yes, I just ordered a whole.
Okay, and here's like a 4-pin connector, and okay. So I'm gonna. Yes, exactly. I need one of those. Actually, I've got lots of these. What I mostly need is these, and I don't know. There's lots of different crimp-on pins, and I don't know how to specify these in particular, so I'll know what to order.
These are on Mouser and DigiKey, and this has everything from single and dual 1s up to looks like double 6s and single 6s, and it has both male and female pins. And this is
Yeah, I got the same thing from Japan. I think it was $11.
Yeah,
And what are they called? What are those connectors called?
they're called crimp pins.
No, well,
No?
Now there's Molex has crimp pins. There's thousands of things called crimp pins, and they're all different sizes.
All right, I'll find it.
yeah,
I usually call those things JST and a dash something or another. I've seen a bunch of those. They're not exactly those things, but they're what used on most of my 3D printer boards all over the place. They're like JSTX 8-XXHs.
Yeah,
Yeah.
JSTX.
Molex makes them, and that's
Say
Molex.
again,
Molex,
Murray?
Moelex.
You can actually, you can find them on the Adafruit site if you just search for crimp pin, but they're called JST-PH or JST-XH pitch connector. It's a 2.54 mil or a 2.0. So basically it's either 1/10 of an inch or 2 mil connector kits. And you guys, we all want 1/10 of an inch. So I guess it's, put it this way, you can search on Adafruit for item 4423. They're out of stock, but that will give you a lead into what they are. They're called JST-XH.
So do you guys use the
JST-SXH?
Yeah. Now they're different though. There's two kinds. These are JST connectors and have the little tiny hooks and everything to hold them together. The ones I've got don't have that. These are just the little black things that just slip together. The JST ones are the ones that have the little kind of extra plastic hook that holds it together.
No, I don't want those. What I have is, I have these long rows of pins. Let me grab it.
Then that's not what you want. Then let me find them. I'll find them on Mouser. Oh, actually, Robot Shop sells them too.
Can you see these?
Yep.
I want to be able to make those connectors, and I have to make several dozen, and I have enough connectors to make maybe 5.
Yeah, I've made a whole bunch of those things for my robot, basically.
Yeah, I think Crimp's got it on Amazon. That link takes me to just what you need, I think.
Yeah, Kareem's put a link in the chat there, Dave.
What's that?
I'm wondering, when you guys do this, what kind of crimp tool do you use? Because I know when I've looked at these different kinds of connectors and crimp tools before, there's like a unique crimp tool for each style of crimp pin, and they all have different kind of schemes of crimping. So that's just a regular old clampy thing. 3 steps up from nose pliers, right, Dave?
Yeah.
Some of them as well.
Dave has the really high class ones. Yeah, he's got the high class ones. I got a cheap Radio Shack ones that were, I think, $15 as opposed to the $60 or $70 ones.
Yeah, this one was like 60, but I think it's a Canner's purchase, so it was probably 30.
But some of them, they have like little inserts because they'll bend the pins in certain ways at certain times to bite into the wire, and it's different for the different kinds of pins and a different wire, and even the different insulation on the wire. So there's,
and the higher dollar ones have different bits you can put in there to switch out for the different pins and things if you want to go all that crazy.
Well, you could take the masochist route that I do. I actually hand crimp them and solder each one.
That's what I do.
Soldering will get you into trouble. It makes them brittle and they'll break off.
Well,
I just beat them with a hammer till they fit, man. That's what I do.
I've done it both ways, and I think that I find them. I actually don't solder. What I do is I strip the end of the wire, and I tin the end of the wire.
Yep.
And then I crimp it onto the tinned wire. I don't actually solder it to the pin, because if I solder it to the pin, it makes the pin too big to go in the hole.
No.
It's pretty tight.
All you need to do is tin the wire, crimp it on with I use a little pair of needle nose, and just touch the soldering iron tip so that it melts on the inside. You don't have to add any extra solder, and it gives you that physical connection then as well. You can't pull them up.
I have had other people tell me, "Oh no, you don't want to solder those. You want to put them on the bare wire so they'll bend and not break." What Dave was just saying.
Oh.
But that's what I've always done.
I've made
printers. for me, my 3D printers, there's a couple different thoughts on that. I'm using ferrules. They're a real nice thing that you put them on there, and I got a nice crimper for it. But there's two camps: solder and not solder. Solder and not solder. Yeah, because what it comes down to is because you're usually pushing 8 to 10 amps. And what they say is, if the solder's too hard and then you don't get a good connection on it, it'll start arcing, right? And now you got heat, and all that goes bad really, really fast. So I can't tell you how many of these little insert green blocks have gotten burnt on it. And they go, well, what happened here? And I'm like, well, you just didn't have your stuff tight enough. You didn't have a good connection, which is essentially what it is, because it creates arcs, resistance, heat, things burn up. And so everybody says, well, solder them in there, solder them directly on. If you want to solder them directly on the board, I guess you're okay with that. But that kind of limits what you're doing. And if you're going to use the crimp thing, it's best not to solder those things. At least that's the going thought. Because
I think
so Harold, you're saying that when you solder them on, it keeps them from flexing inside the connector, and therefore that they don't make good connections.
It's one of these things where you got a screw terminal where I say screw terminal. It's the screw clamp terminal where you're putting in the wire and you're clamping down on it. And when you do that, the solder's hard enough, and if it's not exactly smooth, so you don't get a good connection on it, you'll start arcing between all that stuff.
Okay.
Those ferrules, when you clamp down on that, it makes a nice square, solid, lots flat on top and bottom. I stick it in, I clamp it down, and I've got a great connection. But what you're doing, is a little bit different than that. So
I think the thing is that these basically have a limited size of. I'm using 26 gauge wire, and I think 24 is about as big as you can practically put into these things. Yeah. So they're not going to hold a lot of current anyway. I'm not going to hold a lot of current
anyway. Yep.
So, but I've made dozens and dozens of these little things so far, and they're a pain in the bum, but they work really well, and you can't pull them out. I mean,
it is the most tedious part of robot building, but it's also the part that will really come back and bite you on the ass if you don't do it right. You spend time trying to track down things that look like they're software problems when in point of fact they're intermittent connections or something.
Just a cable.
What I found was actually happening was that I was making lots and lots of little tiny connections, one-on-one connections, and they were often grouped into 5s or 6s or whatever. So even if I had that what do they call it, jumper junkie or whatever, this the rainbow connections of these little one connectors, I found that I kept making mistakes. So what I would do is cluster them into a natural group of, and then I basically now just have to plug a whole plug of maybe 10 or 15 connectors. And I don't have to worry about accidentally plugging something in the wrong place now, because my whole robot is now a collection of either 5s or 10s or, it's a bunch of manufactured connectors now rather than individual connections.
Plus, you can actually pull those pins back out. With an X-Acto knife or something, so that they can be swapped around if you don't have them in the way. Okay, this brings me to my third question, which is, this is one of my breakout boards. This one is unpopulated, and right down here in the corners, here and here, is where those very connectors that Harold was just talking about, where the power comes in. On this side, it's the 5 volts for the whole board, and on this side, it's the 5 volts that just drive the servos. And Ron has very carefully supplied a place to put some small decoupling capacitors, which he's labeled 30 and 31. But nowhere in any of his documentation does he define capacitors 30 and 31, nor will he, Ron, are you here? Nor will he reply to my entreaties in email. So my generic question here, I assume those are there to try to remove any noise from the power supply line just before it gets to the rest of the board, and that maybe something like a little ceramic, although he has them marked as polarized, he tells me which side is plus. So I don't know if that was just a nicety on. But one of you real engineers, as opposed to somebody, for example, with a degree in music or filmmaking, one of you real engineers might advise me, what size should those caps be?
So where are they? I mean, are they on the input side where the power comes into the board?
Exactly.
So they're across that before any voltage regulator?
The voltage regulator is on the STM card itself. There's no voltage regulator on this adapter board.
All right. Okay. So power comes in the adapter board. It has those magic unspecified mystery pads for some capacitor. And then, but that's in parallel. The lines just go straight on to the board, the processor you're trying to supply.
Yes.
Okay. And then this is 5 volt or 12 volt, or what's the?
It's 5 volt.
And how big are the pads? Is it?
They're a little tiny. They look like you might put a little cannulum or something in there.
So,
Yeah, but
so they're not sized for a bulk capacitance. So they're going to be there. It looks like they're just there to take high frequency crud off, to snub it.
Yeah, yeah. So what would that be?
Whatever fits. I mean, really, just pick a ceramic. So some of the caps do better high frequencies than others, and I think ceramic, as I remember, because it's been years since I've practiced in this, but I think the ceramics do relatively good with high frequency noise versus like electrolytics. They don't do so good with high frequency. I can't remember about tantalums.
Tantalums, I think, are in between the two.
Yeah.
But you would suggest that a small ceramic capacitor, something that's going to eat high frequency noise off of the line.
Microfarad or two. Yeah.
Yeah, as many microfarads as you can get that's, say, 16 volts that'll fit in your pads.
Yeah.
Okay. I'm writing all this down, gentlemen. So
I'd say 16 volts just so that you have plenty of margin.
David, I joined late, so are you talking about on a Nucleo board or you're on something else?
A Rongle board.
He's talking about Ron's adapter board.
I'm talking about the very board that you now have 2 of.
Yeah, what about it?
Actually 3, since you have one of the originals.
Yeah, the one messed up. I don't know if I still got that one. So let me get it here. Find it.
Yeah, I don't know if you can see here. Pull that in close, but you see here and here is where the terminal blocks mount. And on this side, it's for the servo power, and on this side, it's for the rest of the board's power. And then right beside that, right here and here, are places he put to add caps.
David, I can't see it. Can you bring it up a little bit?
Just, yeah.
There you
go. Is that good?
Yep.
Okay. Hold on a second. Let me see where you are. Okay.
And are the caps at the top edge or kind of in the caddy
They're
corner?
right behind the terminal strip.
Right behind. Okay, yeah. So they're. Yeah, I think it doesn't look like you'll be able to put much more than like the microfarad ceramic square body ones.
Well, and if they get too tall, they'll run into the board.
Yeah.
I can always fold them over, so that's probably not really a problem. Well, I will say, since I couldn't figure it out, I've just been running it without them. I'm not sure it makes much difference, but of course I'm powering this off a nice clean bench supply right now, and not something that has noisy motors attached to it and servos and things that are putting a bunch of noise on the power supply.
But at the end of the day, I think you'd hope that the processor card itself has good regulation.
Yes, and it does. This is really, the power from here not only goes to the processor card, but it's the power that goes to all the I/O pins. So I don't know if I have another one here handy. Hang on a second.
Yeah.
Hey, Ray.
Yes. Can you hear me?
Mm-hmm.
Okay. Yeah, my T-Mobile is having problems today, so it's a joke.
Okay.
What's that?
Bad day for T-Mobile.
David,
is showing the power coming into his
Okay, so you can see the here and here where my fingers are.
Yep.
That's where the and then you can see underneath the edge of the Nucleo board is where those caps would go.
Yeah.
So there's not a lot of room.
Yeah, David, you probably want a small tantalum capacitor there. Let me look at something here.
Small tantalum.
Oh, we have 2 votes for ceramic and 1 for tantalum. Who else wants to weigh in?
I don't know. I like those little plastic rectangular ones, the little boxes.
Excellent.
Yep.
I don't know what those are called, but those are great.
Yeah, I'll be honest though, David. I don't think they'd make much of a difference anyhow. I think the biggest difference is how the layout and regulation is done on the processor itself, and then how long your cable is and whether you're taking care on getting it from where it's coming to where it comes in.
Well, I think anything that depends on me being a careful builder, that's probably a mistake.
What are these things called anyway? These little kind of rectangular ones.
Cap.
Little rectangular ones. I forget the name. I mean,
Yeah, in my previous attempt at building things, I was going to build a modular synthesizer modules or something like that. And I stocked up a whole lot of these things. So I've got tons of them. And they're nice. They fit right down against the board solidly. And they're marked well. And they're not that expensive here, even in New Zealand.
And they're stable over temperature and they're accurate.
Yep.
Relatively speaking to other cap technologies. I mean, those are the style that we use. The ceramic flat ones like that is what we used when we did when I did the laser rangefinders, when we did mil spec electronics.
Mm.
So those are basically the really high spec ceramic capacitors.
Yeah, they're just well controlled, right? So they're once they make them, they hold their values and they hold their characteristics over a wide range of conditions: temperature, humidity, life.
Yeah, I mean, all they really are is basically a little plastic box. They put,
Somebody's got.
I think it's Ray. Ray, you might
Yeah,
do the
it is.
mic off or something.
Doug, what do you have
I've
there?
got my mic off.
That's a, this one is a little tandium cap. This is 10 microfarads at 16 volts. And this one is actually a double. So you would only need half of one of these. I know I've got some singles somewhere in here, but.
Well, I probably have some also let me dig around.
Yeah, I got these at Tanner's a long time ago.
Oh, well, I'll drop by Tanner's to get some.
Yeah, okay, go do that.
Yeah, go and do that.
But what I'm trying to say is, if one of those is supposed to supply the servos. All right, one of those is made to supply the servos, if I remember right. And
that's correct.
Servos are notoriously noisy. So
yeah, I found out long ago that the servos have to be on their own power, separate from the microprocessor.
And this probably, Ron, he probably just put it there to, and you can always ask Ron. He can
he won't answer me. He tells me that he ignores me. I will say though, I was looking at this board when I was putting it together last night, and I should compliment him here behind his back. Just what a great job he did. It's so professional. It's so well labeled. He's got little caps spread all over the thing. I mean, it's really, really nicely thought out. And he just did it because I asked him to. But kudos to Ron. He's really good at what he does.
Yep.
Yes, he is.
Yeah. Anyway, so I'm just saying is, I suspect that's just kind of like what Carl said, is they're trying to knock out some of the high frequency noise, because you can't do a lot of filtering there underneath the board, but you could put a 10 microfarad pendulum there with no problem. So the two suggestions are both basically the same, which is one said ceramic and one said tantalum, but they both said a few microfarad to 16 volt. Well, you might even go, like I say, if you're doing just the ceramic, you probably only want 1/10 of the microfarad.
Is that right?
Yeah.
Okay.
You probably could get up to 20 or 30 microfarads in the ceramics.
Yeah, I'm just saying is that you usually use a small value cap to knock off your high noise.
Yeah, 0.01.
All caps everywhere.
Yeah, that's why he's got these 0.1s everywhere. You know, the only question,
So when that little tiny cap, and I look at it underneath my magnifier, and it says 104, that's a 0.01 microfarad, right? 103 would be 0.1. Somebody tell me if my math is correct.
I just Google it nowadays.
Yeah,
That's above my pay grade at the moment.
yeah, I would definitely Google it because some of the codes are not obvious. Okay. It's really, when you go look at it, you know, you do need to get one of these though, if you can, or from our sponsor next time. This is from Mauser. Okay, they gave them away to us, and you know, it's got all the sizes. You see them over here. The sizes are different. Yeah, I mean, it's really very useful if you're going to be using a surface mount. So, and like I say, he just gave, you know, it's even got line pitch, I think, over here on the corner. Little tiny holes and a whole bunch of things, even some symbols. But anyway, I'm just saying is, you need to get one of these. If they come to one of our events, or we go to one of their events, it's usually free. They hand them out.
So I think those are all my questions. The main thing I wanted to communicate was that I had on Dave Ackley's. As a matter of fact, Dave gave me my first Nucleo board some years ago.
Yep.
But this newer one, this F446, it's the F446RE, and it's a superset of the basically the same mask. You know, you're limited by the number of pins that come out of the processor. But this one gives you 3 USARTs, which is what the 411 had, but it also gives you 3 UARTs, which is all I need to talk to my serial LCD and that sort of thing.
Yeah.
So that solved my problem, and I've just spent, Dave, if you want it, whether you want it or not, I sent you the document, the pin IO document that I came up with for this.
Okay. Now, incidentally, if that doesn't have enough on it, they have a Nucleo 144 board that has that part in it.
Okay, here's the downside of the 144 board. It's a lot bigger.
Yeah.
So, but I love it. I love you have port D and port E pins. I love that part. However, it's way too long to fit in any of the spaces on my robots. Plus, it will not fit my nifty little Nucleo breakout board.
Well, I figured that, and that's why I didn't suggest it.
Yeah, I had already looked at it carefully and had been envious and then rejected it because it was more work that I wanted to do.
Ah, okay. Yep. Well, that's why I pointed out the 64-pin version.
Well, and I appreciate it. This looks like it solves my problems quite nicely. So thank you.
You're
I
welcome.
got a kind of related question. Does anybody have any experience with these Cypress microcontrollers?
No.
No.
Way back when I played around with the Cypress, they have the advantage of being able to, they've got a essentially FPGA kind of capability built into them, which is interesting if you're having to do any analog stuff.
Okay, because they've got one of them is actually pretty cheap. It's like $20 New Zealand actually, and that's pretty cheap. And it has a an Arduino Shield connector on the top, so you can plug Arduino Shields on the top of it, and it's not expensive, and it's pretty powerful. I can't remember how many processors it has, but they look pretty interesting. But I don't know anything about them.
Is Cypress still in business?
What?
Say again?
Is Cypress still in business?
Yeah. They're actually, I went to their website and they've got quite a lot of stuff. Yeah.
Cypress. Okay. Huh. I'm thinking of somebody else, I think.
Yeah, I found it on, I was digging around, I've got an order pending on Mouser, and while I was looking around in there, it popped up, and they look quite interesting. They're like, they've got both 8-bit, 16-bit, and 32-bit microcontrollers.
Do we know if that website is active or is it not active? That would be my thought.
No, I just was there yesterday.
Okay.
Look at Cypress Electronics or Cypress Electronics. Cypress.
www.cypress.com.
They've been around a long time, but I never looked at them.
Yeah, Cypress Conductor.
Yeah.
I have just one more I was going to add to this. I said this was a superset of the 411, and all I talked about was it gives me these 3 more UARTs, but there's actually some other cool stuff. There's a 2-channel 12-bit D to A converter, which is pretty rare on these little micro. In addition to the 12-bit A to D, and it runs at 180 megahertz.
Megahertz? No.
What did I say?
You said megahertz?
Yep.
No, search for SDR? Maybe, I'm asking. I'm guessing.
That's an M4. It runs at 180 megahertz. It's got 512K of flash, 128K of SRAM. And as I said, it's got, in addition to these other parts, it's got a D to A converter, which is kind of a rarity on these little microprocessors. Although it's not really hard to build one. You just run PWM out to a cap and a buffer, which is the way I've always done it. But if you want to generate analog signals, you kind of have to have one. And so that's very cool. I've never had one.
David, what model do you have? What model do you have?
It's a ST M32F446. It's a 446RE.
F4. I'm on their website. I'm just looking. Okay, thank you. Yep, I found it.
And as I say, it looks exactly like
that link in the chat that you found.
I can, except I'm on the wrong computer, but I'll find it on this computer.
Okay, no worries. Cool. I was just All right. All right. So moving around the Brady Bunch stream here. Mr. Anderson? No. Oh, so Mr. Ackley.
Yeah.
Have you had a chance to work on any projects? Any fun stuff going on there?
Well, Ron's up. I've decided everybody else is simulating their robots, so I decided, well, I try simulating mine.
Oh, how's it coming?
Well, yeah, I've just barely dusted off the tip of the iceberg. He's gotten me started on using what is it? Processing.
Processing, nice.
So.
Oh, cool. Well, you better look out, because right after you get a little further on that, then you'll get into Unity and start doing.
No.
Well, that's cool. So are you going to be in line for a demo to show us something?
Yeah, probably in about 6 months.
Good, cool. DPRG time, nice.
Yeah, yeah. I run in Carl Ott time.
Oh yeah, that's pretty. Usually I'm not that fast though. Okay, fair enough. Fair enough. Let's see. So, Mr. Murray, how about you? You've been like just writing all kinds of emails left and right and getting all kinds of questions and answers. I can't keep up with it. I'm so far behind.
Well, if I had
Anderson some answers on search engines, and I haven't even had a chance to read all these GPS hiding things.
Well, I'm a quick typist, I guess. Well, I keep having trouble focusing. I think that's my problem. So I've got two Python scripts that I'm supposed to be working on. One is my slew limiter, and the other one is my PID controller. And I keep putting them aside because they're not as much fun as actually making things. So the slew limiter actually works on the way up just fine, but I can't get it to go down. So I've got something wrong there. And then my PID controller, of course, kind of relies on the slew limiter because I can't just suddenly charge the robot up and have it fire up at 80%. So those are the things I'm supposed to be working on. But I've actually got well, I wish I had it ready. Actually, I almost do have it ready. Let's see now, where did it go? I have a new CAT scanner for my robot, and I can demo it, but I'll have to get it set up. So I might have to come back to me.
All right.
Put it up, but I've basically got a new CAT scanner. It's pretty impressive.
Does that mean you have to find a cat?
You have a conveniently located cat?
Well, I can find him. He's not very mobile.
Okay.
But yeah, so in fact, my partner and I are going to do a YouTube video of it scanning my cat. We just haven't gotten around to it yet because, there's so much going on around here right now. So, but this is the beginnings of it. You can probably recognize what that is. So I've got that on the end of a long arm, but it actually works pretty well. It's anyway, we'll come back to that. So
that's an infrared detector?
No,
yeah,
PIR.
one of those guys.
That's a PIR, right?
PIR, yeah.
Yeah.
Yeah, and you actually, David, I was going to ask you. You use a pair of those with some kind of a barrier between them, so you get a left and right. Is that how that works?
It's actually it's a balance. So when the two sensors in there, the two get unbalanced, that's when you get a signal.
But
I just angled it off.
If you pull it, if you actually look at the PIR chip,
yeah,
you look through the window and you can see it's really two pieces.
But the question I have is, I think if I remember right, on David's SRO4 robot, he has two of them, and then basically which direction the movement comes from.
He's not using any PIRs. He's using real PIRs. No,
I have two separate sensors, and one of them looks left and one of them looks right.
Yeah, but that's not the same thing. It's a totally different sensor.
Oh.
Yes. So what I determined was that
it detects heat, basically.
It didn't really work when the robot was in motion.
Right.
So, and I've got it on that robot. It also can't see through the plastic bumper. So on that robot, it's mounted on a little servo arm, and it extends it up in the air so it sticks up above the plastic bumper. And then one looks left and one looks right, and whichever one goes off, the robot lunges in that direction, as if it's going to attack whatever movement it just saw.
Yes, that was the idea. Let's see. I might be able to. Let's see. ROS. I'll give it a try. It's the CAT scan. All right, I'll do it once without showing you to see if it even works.
The dry run.
What's going on? Huh? It's not working. Oh. No, it's not working. Oh, sorry. I'll have to do something. Something happened. I wasn't really ready for a demo.
Who of us is? But that's cool. We'll just move on and come back to you then. So
okay.
So I think next in line, Mr. Harold, how's it been for you this week?
It's been all right.
Have fun, or you just stuck working around the clock?
What now?
Have you had a chance to have fun, or you just stuck working around the clock for this new client?
You folks can't really see because I am not allowing you to see pretty much. I know that my background hasn't changed much, and yes, it's got lots of stuff in that thing, but my foreground has changed tremendously because basically all my work stuff, on my workbench where I'm doing all the things, has gotten just cluttered to the point where I couldn't do things, and I'm like, okay, at the very least, I need to dig my my lab machine out of the back of all of that so I could see if I could add another USB hub in it so I can make some things happen. And so I could get another device kicked in because it said it doesn't know how to kick it in and those sorts of things. And oh, what am I doing? Yeah, I want to show off a little bit. And
Harold,
so,
are you saying that did you clean up?
I actually cleaned up. And when I cleaned up, it's more along the lines, I moved all the junk off of my workspace, reorganized the stuff I cared about, and the stuff that's still junky, well, some of that got thrown away, but not nearly enough of that. And I think I'm preaching to the choir on that. So
I think you should do that every 20 years, whether it needs it or not.
Yeah, about 20, quite 20 years. But
yeah, clear plastic bins are your friend, I guess.
Yeah, so you get enough of those things, and yeah, and I've got tons of those things too, right? And so I've been doing a couple of things this week. One of the things is, let me pull up my Dealy Bopper here. I couldn't get this to working last week, and now I know I can get it working now.
OBS Studio.
It should be working now. Come on, don't do that to me. Don't do that to me, because it was working.
Harold, I have to thank you, by the way, Harold, because when my demo failed on this, what you said was exactly right, and I figured it out afterwards. So
yeah, what? I can't even. When I was right about something, get out of here.
You were absolutely right about it. All I had to do was to go to the right switch and flip it. I wish I could convey the same vibes back to you now, but we've got black screen.
That black screen, I can't. Now I'm not happy. If I've got power, I'm not happy now. What I was trying to show you was I got my GoFranco unit working on here, which I didn't think I was going to be able to, and I'm still having some problems because that should have come up with my Latte Panda screen on there. That I've got it in the way. I plug its HDMI output into the GoFranco, the Franco into my desktop PC that I can see. It's right there. And I've got this unit here in the way that's supposed to be sucking off a bit of USB to look like a camera, and that's what I was trying to show you, because it was working. And I was trying to make that happen. So I was happy to make that work, so then I can now show off any number of things going on in other little projects. The other thing that go ahead.
What kind of camera is that?
What type of camera?
Yeah.
This right here.
Here, it's a digitizer, right?
No, it's a here. Let me just unplug it and I'll bring it up. Because obviously it's not working, so not a big deal. Okay, this is a GoFranco. It's the name of it's a Prophecy, and the bar for this type of technology is an Elgato, but I've seen those things go from $150 when they start before all the junk started, to about 2 weeks into it to $250.
Yeah,
while I was watching it, it went from $250 to $550 within the span of about 10 minutes because everybody was buying them out. Everybody's now YouTube creators from home, so they're buying these things all over the place. So I got a kind of a not the brand I wanted, but still the brand. So I've got this is where the USB comes out, USB 3. This is where the HDMI goes out to the monitor, and in here is where the HDMI in goes in, of course, and that's how I power it. It also has an audio in as well if you want, but this thing right here sucks out that HDMI signal and makes it look like a camera to OBS. So then I can show that thing off. And it's pretty cool. It's working really well up until I wanted to show it to you folks. And well, there you go.
Isn't that always the way?
Yeah. And the other thing I've been working on is this list of stuff. Let me put me back. So I've decided to get more serious with my YouTube channel because I've had one for 4 years. I've got just over 100 subscribers, and that just happened recently. And something caught my eye, and I've got there's 3 questions I need to answer. This is like brain working soft stuff, so it's killing me to have to do it. Yeah, it doesn't involve touching things or banging some code, right? So what are all these things? And I will make sure that you will get inundated with them, because I'm doing a blog post and I would like somebody to help me vote. Because the thing is, I need a title other than I want to show neat stuff. That's basically what I've got on my YouTube channel. It needs to be more targeted. And I've been running through ideas. I get them during the day and I've been jotting them down. And so far, I've got a page and a half of double spaced lines. I think can you see the guys? Maybe the
Harold, I got a suggestion. Just call it cat videos.
There you go.
I would like to be
Yeah, but with time.
that I'm going to do.
Crypto cat videos.
I had some friends who had a funk band, and they named themselves Totally Nude, No Cover, Free Beer. That was the name of their band. So that when that got put up on the sign in front of the bar, tonight, totally nude, no cover, free beer. Oh, I kind of like that. You might think of calling yourself the London Philharmonic Orchestra.
Yeah. They might have something to say about that. But anyway, I'm trying to get a catchphrase or a line. They say you need to be pretty targeted so somebody can read your tagline and know why they would be coming to see you and why you would be there, other than just things I want to show, which is essentially what it says now. So I'm trying to
do what a lot of people do and just lie.
Well, see, but I'm not that person. I may lie about a bunch of stuff, but not intentionally. You know?
Okay.
And so I've got things like making things easy, or making useful things, easy. Things like maker of useful projects. Well, I can't really say useful. Maybe I put that in quotes, or something.
So Harold, let's just get on your list. What are the first 3 that come to your mind that really jump out at you, Harold?
That jump out at me?
Yeah.
The making things easy. Making things, easy. Because you guys have seen what I do. I don't do anything too terribly difficult on the thing, or I probably couldn't do it. And most other people can most people can do this. They just don't know how to get started. Like my electronics for programmers thing. I want to do some of that. I want to do some 3D printing thing and show people how to do some of that. The thing is, I don't want to pigeonhole myself into 3D maker of all things. I want to keep it into the electronics and technology sector. Like I've been doing cooking things on Sundays. If some of you follow me on Facebook, you see my Sunday night cooking things. But that's just me doing that for whatever. That's not what I want this to be. I want it to be something that, it's tech, it's hopefully going to be interesting. And like one that really speaks out to me is one of these over here, like, exposing the magic of making things. Because everybody thinks this is magic stuff, and everybody I'm talking to now knows that this is not magic. There may be some insane or inane stuff in there. There may be some very detailed things to worry about, but it's certainly not magic. You just need to get into it, right? And I do a little magic too. I got a little card trick or two here, there. So that sticks out at me. And then,
so you want to spoil the magic for everyone?
Yeah, I wouldn't be really spoiling the magic.
Harold,
Harold,
I think you need your name in there. It needs to be personalized.
Okay.
Harold.
Well, the name of my channel is Harold Pulcher, so I'm not. That's the name of the channel. This is the tagline that goes underneath that.
Well, then the tagline is "Spoil the magic."
Yeah.
Spoil the magic.
Spoil magic. Simplify. Simplify,
that.
spoil magic.
Spoil the magic. I'd go for that.
Or the magic of making things.
Sorry, Harold. That's the trouble with this. You put something out in the mirror, it just bends things. It's like a funhouse mirror. It comes back all the
No, this is great, because what's going to happen is I don't think any one of these things is going to come out, but I imagine once I go through this and do some what do they call that thing? What are the homiletics? do some homily type stuff on this.
There you go.
I bet you will find something way cool. I just got to get enough stuff against the wall to get cool, right? Or get the real thing I'm looking for. Magic of making things. Oh man, that's actually pretty cool. Because I could do magical effects, like I could show you how to make a magical thing, and that would still be doing 3D printing, 3D design, maybe a little electronics in the middle of the thing, and then say, oh, let's talk about electronics today, or let's talk about this. You know, I had to use, you know, I envisioned seeing this. I had this new project. I had to use name whatever discrete piece of thing that you need to do. I didn't know how to use it, so here, I wanted to show you me using this stuff and figuring out kind of what you could use it for. You know, and I know there's tons of stuff out there doing this, but one of the things is if there's tons of people doing this already, it's because I don't know if they're successful or not, but at least somebody's watching it. You know, it's not like I'm out there making underwater basket weaving, although I would watch that. But this is a thing. So I don't know. This stuff is thinking about this stuff and being introspective on yourself is, that's some of the hardest stuff I do. I don't know about the rest of everybody out there. Some of the hardest stuff I do on actually looking and coming up, and then I've got to worry about doing some blog posts and doing a couple other things. It's so easy for me to get caught up in the minutia of that one thing's not right there. I need to make that thing right before I can go one step further. And the realization is that doesn't matter because the only person that cares about it on the planet is me. And I get past that. I need to get past that on some of this stuff, and some of it does matter, and some of it will. It's just hard to know what does and doesn't sometimes. It's easy for me to get squirreled away when this is so hard for me to go through. The easy thing is now. See, I've got a huzzah on my desktop right now, blinking away as we're doing something because I had it laying around and I forgot I had it, and I go, well, let's at least make sure the thing blinks. And so as we've been talking, I've done that because that's easy stuff because I know what that is. When I should have been doing all this a bunch more. So that's what I'm in the middle of for the last week or so, whatever that is. And thanks for the suggestion. That Spoil the Magic, that's really good. And maybe I could take that and spend a little bit more with that. That's really good. At least
what you need to do now is type that in Google or something and see what the search engine pops up.
And do stuff like that. I pick up a thesaurus. I go to thesaurus.com and I start jacking in these words here too and see if I get other inspiration. That's what I've done in the past.
Yeah,
an inspiration of where to go come up with the words, and I eventually come up with something pretty good, but it doesn't come easy and it doesn't come quick sometimes.
But it's a good journey.
It is.
And it keeps you distracted from what the other things you want to do.
Yeah, especially when you got especially when you got data. This is actually really fun. As hard as I think this is still fun stuff to do. I mean, especially when I'm dealing with people on a daily basis. Where I know you guys work with folks as well. I've got a software development team, still trying to figure out not how to push their buttons to be an evil, vindictive person, but how to push their buttons so that we're all working and going forward in the right direction and know what makes this person tick versus the other person tick. And we got a couple of folks that are isolationists, Superman. One of them happens to be female, but she's Supergirl, I guess you want to call it that. But and pretty much on Teams, I don't know if you've got that in Teams. There's this concept that a friend of mine came up with several years ago, and I believe it wholeheartedly. Superman is evil, and what it means is that usually on a team you'll have somebody that's a Superman that just goes and does and goes and just hammers it all out, and then they're just doing what they're doing, and they're not trying to be evil, mean, or nasty. But what they do to the rest of the team is somebody will be working hard to get something. They'll jump in, swoop in like Superman and go, oh, you need to do this, and just bang it all out and be done when the person was getting there. But now that person is denied this person's the satisfaction of finishing the thing and figuring it out. Because we're all in this for, damn, that worked. That's awesome. Well, they just denied them that. Also, when they will go, well, I was here till midnight last night and I'm here at 4 o'clock in the morning because, well, I had nothing better else to do. Now that sets the expectation for the people you're doing work for that that's going to happen too. And that's an evil thing too, because if you can't have a sustainable pace as you go forward, you're going to burn out. That's just all there is to it. So that's where that Superman is evil concept comes from. And we've got a couple of them on our team. Not that I'm going to squash on that or try to squash it. I just got to be aware of that when it starts happening, I've got to figure out how to deal with all that. And so
I have a question.
This reminds me a little bit of one of Feynman's colleagues out, I guess it's at UCLA, was talking about what it was like to work with Feynman, this Nobel Prize winner, this genius, this brilliant guy. And he said, but the problem is that his method is not something you can teach. He said, and that's what we do. We teach scientists. So here's an example. Feynman, first he would write down the problem. And then second, he would think about it really, really hard. And then third, he would write down the answer. Well, that works for him. But that's not really something you can teach anybody else.
Yeah,
I thought that was interesting. He said it's hard to work with somebody that's smart because nobody else around him can learn from him. My wife, who is an opera singer, has said the same thing about studying with famous opera singers because so often they don't really know how they do it. So they can't actually transfer it to you. They can show you. They can say, no, just sing it like this. And of course, it's glorious coming from them.
But the way they're doing it, they can't even articulate what's going on in their brain because they've never actually had to put it into words to see somebody else.
It was always easy for them.
Yeah, I had an engineer that I was mentoring one time, and he says, "Okay, Dave, that's enough. Let me go off and make my own mistakes now."
Yeah. And that's how I work. I was telling him today. I mean, with these things like this, all this stuff goes on there. It's just, I can read so much about a thing, and let's go try it. And then I'm like, oh, that hurt when I shocked myself. Maybe I shouldn't be doing that. And at some level, I'm going to get something to work and go, ooh, that worked. What? And this book says that's supposed to do this. Just one more of these. Let's try that. Let's go do that. And I pick up a bunch of stuff that way. And I think there's more people to do that than not, especially in this tech industry in the world.
So are you have you heard Agile or watered down or anything like that? Are you into programming those terms?
Hit me with those terms. Agile?
Yeah.
I'm all Agile. We do stand-up. We do Scrum.
Okay, because we've been doing that for about 7 months now. So it's interesting when you get to that type of small bit-sized pieces in theory.
Yeah, there's that whole waterfall versus Agile versus thing that goes out there. The transition from what most people consider to be their workforce, which is a lot of people, there's some version of a waterfall. We design it all up front and go down, and then you just work on it and you deliver it, versus what the Agile mindset is, where in 2 weeks, I'm going to provide you something of value. Now, what is that value? It could be that in 2 weeks, this is a stupid thing, I'm going to show you this LED light blinking because that thing has to blink before your whole rest of thing can even start, right? But I'm going to show it to you in 2 weeks because I said I would. And what it does two things. One, I set a goal. I have a goal. Now the person I'm doing it for you now trust you just a little bit more than they did before because you did what you said you were going to do at the end of the 2 weeks, instead of having this monolithic thing that shows up and it's like, that's not really what I wanted. Yeah, but that's what you asked for. No, not really, right? This keeps that conversation out of the picture and builds up the trust along the way, more than just that everybody's like,
well, that's the theory, but the catch is you have to have bite-sized pieces, and you get management that doesn't understand that.
Yeah, and it makes you think. It makes you think more along those lines. It's like, oh yeah, I need that web page to do this. Yeah, that web page does a bunch of stuff. How about we have it not? We're going to do all those things, but how about we start right here? How about we take one bite out of that elephant and figure out what that bite is? It makes you think about that as you're going forward. And so it is a different mindset. Some people like it, some people don't. I kind of like it because I think the clients that I have, they're seeing this, see value in it. You take some about 30 days or sometimes 3 months to see what's going on, that's how it's going on, but then they finally get it. We've had several of them said, you know what, we're going to miss you guys because, man, this was really working well. And, 2 years before that, they were like, man, this ain't going to work at all. And now actually got them in the mindset of thinking that. They're even to the point where like, hey, we can do this. No, that's too big a chunk for you. We want you just to do this. And we have the people paying me, limiting what they want us to do because they're in the mindset now as well. And that's what they get, what they expect. Yeah, it's a different mindset. Yeah.
I can do a
Anyway, I
demo.
can go on and on about that for all that stuff for a long time because I'm indoctrinated into it 9 ways a Sunday. But
Mm-hmm.
9 ways a Sunday. But that's not what you guys came here to.
Passionate about it. Yeah.
Yeah. Yeah, I always do. And also, you guys got my contact. If any of this stuff comes up on any of this stuff, and you want to know something, just I'll answer questions. Carl knows I'm around all the time. Sometimes in the middle of the day, crazy, but
yeah.
Well, Carl, I can do a demo now.
Mr. Murray, you got it all queued up?
Actually, it was me and Murray. We were teaming up. I was going to keep you guys busy until he was ready to demo.
Nice.
You were the shill, right? You were the shill.
Hey, Murray, you can send the check to my PayPal account.
Yeah.
That's all right.
All right. So can you see the robot now?
Yeah.
Yeah.
Okay, here goes.
Ooh.
Oh, that's sexy.
Now,
It's sexy.
it's now waiting until everything is stabilized, and it won't go into trigger mode until everything's not moving. And now it's waiting for the cat.
I like how it thinks.
The cat now walks.
Oh.
Yes.
Now that's fantastic.
A working demo.
Yeah.
So the cat will then promptly pounce on the flashing lights that I see.
He's meant to be mesmerized.
And I think it'll attack the lights.
Hypno cat. That's pretty cool.
Well, I used to run my big robot around indoors when I was first working on it, and I was always worried that it would run across a sleeping cat tail or something like that. But I found out that it is actually impossible to run over a cat. They just flow away from it. It's like water. It's like they just flow away from it. So never once did it.
No, I've actually already ran my robot right into the middle of my cat. It hit him right in the gut, and he just sat there.
And looked at it.
He's kind of chubby.
Why you bother?
Yeah.
Gonna say the cat video people aren't gonna like that.
I'd like to revise and extend my remarks. Just in terms of what Harold was talking about and how it applies to robotics, because I think everybody here has built enough robots to understand how this applies directly to what we do. And often when there are people who are new to building robotics, they start with a big, complicated idea of what they're going to do. I mean, they're already up at the level of Beethoven, and we're still trying to figure out how to make a one-cell creature survive. And basically, my experience is that successful robot building starts at the other end. What's the most rudimentary thing you can get working? And then what's the next most rudimentary thing you can then make little tiny steps and build from the bottom up, and not try to start with, I'm going to build a robot that will go into the kitchen and fetch me a beer. Where have we heard that before? I'll tell you what it reminds me of. In the early days of personal computers, when I asked people what they thought they would do with their computer, they always said the same thing: balance my checkbook. And that just seems so mundane and pedestrian and boring. And the same thing, you're going to get all this robotics technology, and what you're going to do is have it fetch you a beer. That's really the highest thing you can think of.
Yay!
It's money.
Well,
David, what's your point?
Okay.
Nice.
Let's get our priorities straight.
I'm done.
Okay, so with that segue, thank you. Good demo, Murray. That's pretty cool. We can't wait to the next level to see. But
well, we're going to try to make a video with the cat actually involved.
Excellent.
Absolutely.
I can probably actually go a little bit further than Harold. I mean, I've kind of suffered under agile teams for probably over 10 years, actually more than 10 years. And having worked at large companies and small companies where I've been in, waterfall is used as a pejorative most of the time by agile people. And agile, I would classify as a management fad. It does have some ideas behind it, but it really is just a fad that management uses because they want to get something different than what they had previously, which was plan at the beginning and deliver at the end. But that's actually not real. That even in what they call waterfall, you're still communicating with the customer and trying to figure out what they want in the process of design and delivery.
Yeah, the good design team, they're doing that. There's no doubt about that.
And so when I first got Agile training, and I've been trained twice, the people in Wellington who are Agile people who came out to train us, they used the example of building a car using Agile, which made no sense to me. And so they said, well, you know, the first thing we're going to deliver is a wheel. And I, at the end of the question and answer, I said, well, if you design the car and deliver it, you end up with something that fits together. But if the first thing you deliver is a wheel, how do you know if the wheel's the right size? And they said, well, if the project got canceled after 2 weeks and we could deliver a wheel, that would be a success. I said, yeah, but what if after 6 months you found the wheel was the wrong size and you have to redesign it? And say, well, that's just part of the process. And I was like, oh.
See, that's where a lot of people have gotten this wrong.
They were talking about the steering wheel, and you can test that.
People have gotten this wrong. The Agile Manifesto is, I'm not, and I get to use some big worms because I hear them all day. Not that I've done a bunch of research on it. It's a fairly short 10 or 12 pages thing, right? Really, that comes from the Jeet Kune Do and the manufacturing, just-in-time manufacturing from like the 80s. Jeet Kune Do is the martial artist version of it, but the just-in-time stuff came out of the stuff that Japan started doing back in the 80s and those kind of things. And that's where they've gone wrong, is that Agile is just a set of ideas. If it's not working for you, throw it away. Find something.
But that's not what happens in practice, Harold. In practice, the management, the idea that Agile...
There's a lot of management that are strict. This is what we're going to do. We're not going to change because this is what the book says. Those people are absolutely wrong.
Yeah, but that's the way things are. I mean, my current office, which I'm now changing, like I start a new job at the end of next week, and my current office is all Agile, and they're, or partly Agile, they're kind of Agile. And the result of that is that after 14 years, their system has no documentation.
Yeah, that's not necessarily an Agile thing. That's a developer documentation is code thing, and we had that discussion last time, right? And that's a big, and then I don't know about all that.
Well, I don't mean to take this conversation over about Agile, but my point is that if you want to look at, let's say, Christianity versus Buddhism or versus fascism versus this, you look at the results of it, and the result of Agile is things that take a long time almost never get delivered, or if they do get delivered, they get changed in process, and the result of that is often no documentation because things are moving so fast.
Yeah.
But the thing I would say about it in terms of building robots, which is I think what David was kind of alluding to, is that if you use the Agile idea, not the management process, but the idea, first build the platform with the motors and the motor controller and get that running. And that's the first phase. And then you add something to it, and you add, that's actually kind of in a nutshell what Agile is. Pick your problem, make it small, get that working, and then move on to the next thing. And so I'm actually a very anti-Agile person because I have literally suffered.
Yeah, you've had some really bad experiences. There's no doubt.
Yeah, and I'm actually big for designing, documenting, building big systems, and I've done that.
But you have an interesting point, and that's regard to that the size of the reel. You have to have a rough idea of what you're aiming for. So you really need an overview, and then work on the components of the overview. And that's right, where most people don't get it.
Yeah.
But I think to again apply it to robotics and building like small robots, though, is that I agree with David's main point, which is if you're going to start with a big project like the full robot that goes and gets your beer, you're never going to get there. But if you can say, okay, the first thing I'm going to do is deliver something that can move across the floor. And the next thing is to put a sensor on the front. And the next thing, that's actually kind of Agile in its nice way, that you could actually build something that way. And that's, I think, a good way to look at Agile, that if you use that as a process for building robots, rather than designing the whole robot, like the robot I've got here, this has been redesigned 1,000 times already.
Yeah.
But, you know, I never could have designed it at the beginning. But I did build it a little bit at a time.
And you did have at the start of an overall vision for where you were aiming. So, and even if you, this is the thesis that I've had, having worked in both Agile and Waterfall organizations, which were successful in their own ways. And the view that I have is that, I mean, at the end of the day, you need to have some longer range vision. And whichever framework you come from, if you realize that I don't know everything today, but I know about where I'm aiming, so I'm gonna steer kind of in that direction. And then I'm only going to bite off what I can chew over the next period, whatever that is. And then when I think I'm aiming here and then I wind up here, okay, then you look and see the world and you go, well, the vision's about the same, but I'm a little off course. So I'll bite off as much as I can chew. At the end of the day, call it Agile, call it Waterfall, but it's the same basic idea that the further out you go, the harder it is to predict the details. The closer in, the more you need to predict the details.
But Carl, you've just described the scientific method actually in a nutshell.
I was going to go the opposite. I was going to go the opposite way with that. I was going to say he just described intuition.
It's all the same to me. It's one broad. I don't care what they call it.
Well, you know, I work all day long with these scientists, and one of the things I've learned from them is, you know, they have to write proposals to get funding. So you have to kind of know what it is you're going to do. But that's a hard thing to do. You can't say, well, we're going to work on this for 6 months and then we'll have a big breakthrough, you know.
Right.
Then we'll make a sudden realization, you know. So often what happens is they start down the road. They did the best job they could do. They did their due diligence and they wrote their grant. But then they start down the road, something pulls them off to the side, something much more interesting than what they originally started with, something they could not have anticipated before they started down that road. And the good ones don't fight it. They let themselves be pulled off the road for something that's more interesting. But along the way, we found out that, hey, if you do this, you get this result. Nobody was expecting that. Let's look into that a little further.
Yeah.
Even though that's not what we wrote our grant about.
Right.
And in that sense, I find the guys that I work with, guys and women, they do trust their intuition a lot. And so it made me think, what does this mean? What does it mean when you say you trust your intuition? And I think the best I could describe it is something along the lines of what Carl was saying, which is you look down this road, and I'm not quite sure why, but I kind of feel like there's going to be roadblocks down that way. Let's go a different way. I can't really tell you exactly why I feel that way, but I do feel like that headed down that road may be problematic. It just makes me a little uncomfortable, you know. Well, what's going on there? What kind of reasoning process is leading you to a conclusion like that? And as I say, the really great scientists that I've worked with really, really trust their intuition, which I find kind of fascinating.
Yeah.
Okay, I'm done.
All right. Let's see, Doug, do you have any robot-y things, or you want to keep talking about philosophical development things?
Well, let me show some robot-y things.
Or mix them both. You could do a mashup.
Well,
cool. Hey, the Go Franco's back, by the way. I'm showing you the Latte Panda screen there.
We got your Harold dive bell suit, but let's look at Doug first here, and then we'll come back.
Yeah, and that's all right. No big deal. I just was.
So if you look up there, you can see wire stuff, wires. And, yeah. So anyway, I've got the motors running, the encoders encodering, and the Maxi Go board is being powered by the robot. So everything is cool. Now I'm spending most of my time in the Python.
Could you move it back a little bit? Which one is this, Doug? Is this your?
This is going to be
the club.
No, this is going after. This uses the Billmore Robot 2 base.
All right.
But with a Mega, because was going to say, okay, here's where you can go after you've done your Arduino thing, and you go to Mega, and it's using the. Let's see if I can show. It's using instead of the yellow motors that they have in their kit, it's using the TT motors that are from DFW with the encoders on it. Instead of 6 AA batteries, it's using some
LiPo.
650s. So so it is turning out this base is actually you can even put a Raspberry Pi on it, which is probably something I'm going to. It's kind of, I'm thinking I might just release it as a 2020 Club robot, and it's just just an idea that you have a very basic base, and from that you can just screw around the way you want to do.
Doug, is that laser cut?
Yeah, it's laser cut, and yeah, it's laser cut. So
what's it made out of?
It's made out of 1/4 inch masonite.
Masonite?
No, not 1/4 inch, 1/8 inch. 1/8 inch masonite. And it can paint up. You can paint this. In fact, the very first one I made is white. But after I started making 3 or 4 of them, because I've been reiterating through the loop to try to make the base as versatile as possible without, so that with the courses taught, they can just do whatever which way. I think I showed a picture the other day of some of the variations, but this is actually going after the challenge line filing course.
Oh boy. Uh-oh.
So I'm
poking you in the eye, Carl. He's poking you in the eye.
Oh boy.
So anyway, it's my big thing now is going through. I know what I want to do in Python, and I've been studying the MaxiPy MicroPython image API, and I've been impressed so far, but my Python coding is very elementary, so I'm still trying to get that worked through. I want to get it so that, but I can't, for my demo, okay, let's see if you can see this. All right, I'm turning the switch on.
Ooh, I can see the lights.
I don't know if you can read it, but it says something like MaxiPy on there. Yeah, I don't know if you can see it in there. And notice this, look, wheels turning. Wheels. Oh, yeah. Anyway, so I'm really, like I say, now the next big challenge for me is getting the Python code. And I think if I was using full Python and OpenCV, I could get through this a little quicker. But I've found equivalents inside of the MicroPython image API that can do 80% of what I'm trying to get done. And I've just got to figure out how to get those other things done. Yeah, I mean, you can do things like you can erode and you can, dilate and get a region of interest, read the pixels. I mean, you can do all of that. So I'm looking, my next goal is to show you guys this robot running on a black and white test pattern. Where it's going black square, white square, black square, white square, all the way around. And that'll be the first. That's step one, and then you go to the next one, which is I think line width and 90-degree turns and stuff like that. And then the third one, which is I think is the ones that are not white and they're not black. What do they call them? The shades. There's a name for it.
The stains you have.
Yeah, stains. The stains and the acute. So, but I'm still working towards getting step one, where it'll go, it'll line follow through a white line on black and a black line on white. That's what I'm aiming for. That's my first shot.
This is where it starts.
It made some progress this week.
Well, Doug, I feel for you. I'm, as you know, learning Python as well. And that blog post I sent out in the last day was me playing around with a 640 by 480 camera and in Python. And it's not too bad, actually. I'm not using MicroPython. I'm using regular Python on a Raspberry Pi. But
well,
actually,
you have access to OpenCV.
Yeah,
A lot of tutorials on how to do different things on that.
Yeah.
fact, let me see if it's up here. Give me a second. Back one. Okay, I'm gonna put this just briefly on. I found this, and it's from your neck of the woods. Murray is from, I believe he's an Australian.
Oh, that's like saying to a Canadian, "You're American."
Yeah, but I mean, it's still a lot smaller body of
yeah.
water. Let me see if I can.
Murray has to hate us a little bit because we're all within 45 minutes of Mauser. We can just we'll call. He has to hate us a little bit, just all of us for that reason.
How, guys, tell me, how do I share? Okay, this must be.
I'm just saying that to a Kiwi, calling a Kiwi an Aussie is just like, they don't like it. They're the big bullies.
Okay, I'm going to share this link, and if I can figure out how to. Okay, here we go. This right here. Can you guys see this?
Yeah.
Yes.
This guy does a fantastic job of this, and he's using a Raspberry Pi and OpenCV. But I mean, he's very clear, and you see it says lesson 1. He actually has a lesson, I think, up to lesson 6, even though they're not all pertinent. But he's got at least 3 videos that are useful. So his name is Out of the Bots.
Yeah, just found him.
Okay, he's definitely.
He knows what his tagline is supposed to be there, right?
See, so Harold, you might want to use that as one of the taglines. Yes.
So anyway, this is. I just thought let me see, how do I unshare? Stop sharing. Okay. All right. Okay. So anyway, that was an exceptionally good YouTube link, and I recommend anybody who's interested in using a camera for some OpenCV type stuff, that would be a good example. And his is line following, but
so was it what? Was it 10 minutes run or 5 minutes for the video, or does it drag out forever? When you said it's
well, I don't know. Did you guys, know that you can speed up a YouTube video, don't you?
I know, but the key is sometimes they'll drag it out forever. Back to agile versus linear.
He's not boring, and he doesn't. And he shows the code. He doesn't have a GitHub or anything. He just shows the code on the screen. But the code is fairly simple. Because it's Python and OpenCV, and he's explaining the steps. Like, okay, I do this, now I'm going to add 2 more lines and see this is what it's going to do. And it's like I say, if you're interested in line following using a camera, this is a good link. Okay, I think that's pretty much all I got.
Nice.
So Carl, you'll have jot that down, or you'll send it out, Doug?
I just found the video and put it in the chat, the one Doug was showing.
Okay, good.
Yeah, all good.
Yeah. John, all you got to do is go on YouTube and just search for Out of the Bots.
Out of Bots. I'll have to remember back to the tagline name, but yeah, Out of Bots. Okay.
So, Mr. John, I think you might be next in line. Have you got those farms attached yet?
No, but in the meantime, I did something else. Back to the problem of not agile, the out of focus problem. In other words, I clean house. So in the process of cleaning a house, I found this. So I actually opened the box because I haven't even opened the box and used it. So depending upon if it rains this week or not, how our weather is.
Hey, John, I've got one of those too.
So good. So I may ask when I get it out of the box, and then I found the book that I haven't read. So we'll see how the weather behaves this weekend. So I may play with those things this weekend, and then depending upon if we get an outdoor contest sometime this year, I did find this to drag out.
Oh man.
So,
cool.
Yes. So I need to. I have things I can do.
You can ride it.
Yeah.
It's almost that big. Yes.
John will just run over everybody else's robot.
So
There you go.
Or you could at least put a cat on it.
well,
And then
yeah,
his
the cat
robot could
dog.
chase it around.
I challenge my cat to that robot any day.
Well, it's 4-wheel drive, so it has the oomph to push.
Where's my cat?
Okay. How big is the cat? Oh, that's gonna be bad.
He's not as big as my last cat, but he's a big cat.
So 20 pounds, 10 pounds.
And he's got a tiny head and a huge body, which he's like a bowling ball with things attached.
Okay.
That's a great description.
Well, yeah, he's the least active cat I've ever had.
So, Mr. Ray, you have a video coming and going. You're in and out. Things to show this week?
Yes.
You got the robot voice.
T-Mobile is giving me fits here. Yeah, the only thing I've been doing. God, there's a horrible echo. Hold on. Can you hear me?
You got the robot choppy going on with your voice.
I can't hear you. Okay. Can you hear me?
Yes. But you aren't getting echoes. I don't know if you have like your
Okay.
speaker on plus
I didn't
or
know we had
what.
an int in the chat channel, man. Okay, I'm using the Lord of the Rings reference, so never mind.
This is like the Supreme Court hearing when somebody flushed the toilet in the background.
Or is that Gregorian chant that we're getting serenaded with?
I think it's Tibetan, actually.
Tibet.
Yeah.
Now
Sorry,
we're
Ray.
or is that UFO tone?
That's UFO
Okay,
man
that's
down.
gonna be David. This is the only one that's moved.
Mr. Ray, we might need to pass until you can get the phone in.
No, that's David doing that, not me.
Dave is the human theremin.
Let's see. Yeah. Anyway, I was working with the rope claws, and there's a little teeny set screw in one of the encoders, and it gets way loose and snapped off the
Ray. Ray, we're starting to get about every 5th second of so. Ray, I think we need to string another wire out to the coconut at your house, to the coconuts and the internet. Okay, we lost him. So he'll come back. Mr. Kareem, how about you? Any luck this week, or still stuck, distracted by more productive things?
So yeah, a little bit of. I'm stuck on robotic things now.
Oh, cool!
Just horrible, ugly code things like translating a C library to Java or Python for decoding the RTCM messages and things like that, and it's just a slog through a bog, and I'm not happy, and it's just going slow. It's just I don't enjoy translating other people's code at all. But I sort of decided that that's the easiest way to go, because this RTK correction GPS is a deep, big thing, and I'm not that interested in it. I just want to get good positioning accuracy outdoors. That's all. So,
Kareem, I thought you already had that working.
Well, what I was showing was a sort of the built-in tools that support that. And it was just running on Windows, right? Whereas all of the robots that we work on are Android-based, and so we've got to port it over and get it working in that environment. And so that's what I'm dealing with when I'm not.
You were able to get some quite remarkable accuracy, as I remember, with your little demo or your little test.
Yeah, that's right. It really is. It seems to be in the 2 to 3 to 5, maybe 5 centimeter range is what I would sort of bank on for most of the situations. I just got upgraded yesterday. I got an upgrade to a dual band antenna. So instead of it being just L1, it's L1 and L2. And I'm running a test on that right now, this very second. Because when I was running just the L1 without correction, it was wandering maybe 40 feet throughout the yard when I was just letting it run for a couple of hours. And now on an L1, L2 antenna, same board, without correction, it's probably down to, I'm going to say a range of about 10 feet. And this is on a stationary, non-moving antenna. And so it's more accurate than your typical GPS. But once you add a correction in there, and I'm not sure I haven't even tried yet adding back in the base station reference corrections, but I don't think that they'll improve a whole lot. What I expect out of the L2 is for the system to be a bit more resilient to different kinds of overhead obstructions and things, and being close to the edge of buildings, that kind of stuff. That's kind of what I expect out of the dual band antenna.
Do you guys understand what it is Kareem is doing? Maybe a brief description might be in order.
Sure. So you guys have heard of differential GPS, right?
Yep.
And there are a couple of different versions of that, and I'm finding this is a big, vast field that, again, I have a limit on how far I want to go down the rabbit hole with it. But there are methods of post-processing. But if you want real-time, high-precision stuff that, for example, you get with surveyors, they have this concept called a rover. And a rover is really just the pole that people take around to be the local reference source for their measurements, and using this real-time correction signal. And you sort of got to pay money for most of these to get access to these networks. But if you can get a reference to another station that's going to provide you that correction with a known location, it can improve your accuracy a whole lot. And I'm not the first one to report on this to the club. There was a whole really well done presentation on it back in what was it, September, August?
Yeah, Ross Melbourne's using this for his approach.
Yeah, so that's sort of what turned me on to exploring this myself. So I am using the modules from SparkFun. It's I don't have it up right now. Don't have the actual model number up. Like the ZFP9 or something like that. Yeah, this is ZFP9. It's giving. I found that local base station in sort of Richardson, and it's close enough to me to provide the corrections, so I don't have to use. I did buy 2 of them, because you never buy one. But I was expecting to use the second one for my own personal base station, and right now it looks like I don't have to use it. So as long as I'm operating it in this area. The problem becomes when you start moving elsewhere, right? So you got about a 10-mile distance to your reference station. And so if you can find one that's out there, especially one that's free, it's great. But if I move, if I take it to like a contest location or somewhere else that's not within range, then I might have to set up my own base station. But yeah, I'm getting about 2 centimeters accuracy when I test with it. And,
wow. Hey, now on the porting thing, this might sound silly, but what about, instead of porting it to Windows, what about just installing Windows on your Android phone?
You know, I guess it's technically possible.
You have. I did a Google search. There's several videos on how to do it. I kid you not.
Those videos have a tagline?
How to run Windows on an Android phone.
There's no accounting for taste.
I'm sure all the drivers would work seamlessly.
No problem. Yeah. Yeah, it's a pick your battles kind of situation, right? I'm trying to figure out what's the overall least effort to get to being able to use these things, and but obviously I want to be able to use them in scenarios that can help my students train up faster. So I don't want to hit them with too many different environments. It's not about software integration for them. It's about learning the basics of operating, moving devices autonomously.
Oh, cool.
2 centimeter accuracy outdoors is just marvelous. I mean, I can't imagine that you would need better than that.
Yeah, it is pretty crazy. I've tried. You can find videos of other people who have done things like mark out with tape a pattern on their driveway and then just move the antenna down across that pattern. And I've been planning to do that. So maybe by the next monthly meeting, I might be able to show DPRG spelled out in GPS readings on my front lawn or something like that.
Cool.
That'd be cool.
But that's pretty much all I've been doing.
All right. Well, hopefully, if you get stuck and this time frustrated with the someone else's code and reporting it, just think it's got to be easier than making Windows run on an Android tablet.
It's got to be.
Words to live by.
Okay, I think that just leaves me. So I have nothing to show this time in demo form. I did make some progress though. And someone was remarking on my geological timescales here, and then I think one David was talking about taking 6 months, and the other David was talking about baby steps first. So last week I made the baby step of finally integrating the 2016 Club Robot Base extension that I did with the Donkey Car software. So it's now actually, over the weekend, I was able to use the Donkey Car web browser to make the motors move on the Club Robot Base.
Cool.
The custom SPI interface that I wrote. So I got values working back and forth in 2 directions. Neither side crashes, and but it revealed the need so that by the next week, if I can do all this, it's not that much actually. I just have 3 things. I have to adjust the seed program now on the Arduino Mega, so that if I hit the panic button, it doesn't crash the Raspberry Pi because of motor EMF. So I have to make the motors, I have to make the panic button slow down gracefully so it doesn't surge on the Raspberry Pi and throw that. And then I have one other thing to make it easier to drive. I have like the motors on the Arduino Mega. So I use this to control. I use this to control the Mega, the Club Robot Base, because it's faster response and you can control it more accurately. So it means I have 2 switches. I have one switch on here that lets me either send the commands from here to the Donkey Car or not. But then I need to add the other switch so that the robot base can either accept the Donkey Car commands or just ignore them. So as soon as I add that second switch in, and then I add the hard stop thing, that's the minimum. Then I'll be able to actually train it around my living room table, dining room table. But then because of these 2 switches, it's hard to tell what state the motor's in. So I thought that I would take this little NeoPixel strip and as a diversion for this week, add that in so I can have lights come on and off and show the state.
Carl, can you show us the other end of that controller, the box that's on the robot?
Yeah, actually, so to do that, let me turn on some lights and try the Harold trick. This is the trick that wasn't working for me last week, but thanks to Harold's magic, I got it working this week. So, so if you look at my screen, you'll see my amazing face. So I'm going to switch it over to this, and then I'll turn on my phone, camera mode.
Harold, did you hear that? He just called it Harold's magic.
Yeah.
I like that.
Oh, I got it rolled off the tongue.
It's simple and it's personal, and it flowed right off of his tongue, didn't it?
And it's true. So this is the other end of it, right? So I have, you can see this on my screen now, right? Yeah.
No, I like that one too, Harold. That's a good one.
Yeah.
This guy right here, I mean, this one's branded Lynx Motion from the robot shop, but you can get them much cheaper off of Banggood when the shipping is working, and it just talks to this.
Carl, all we can see is a little bit at the very far right edge of the screen.
You click on Harold. Click on his screen.
I am clicked on his screen.
There's a push pin in the middle of my face. Or no, it's.
If you click it, you should go full screen.
Well,
I am going full. I am full screen, but yeah, 2/3 of it is water and a mountain, and then a little tiny bit over at the right-hand side is the robot.
That's all that I have set up at the moment.
It's Carl's being fancy.
Yes, I did. I don't have a scene where I can show it the other way. Or maybe I do. Let's see. Yeah, I don't have it set up to do. That's the best I can do, David, right now.
Okay.
All right.
Yeah, so buried in there is a mega way down in the bowels of the thing with the blinky lights hiding in there. There's the mega. Oh, isn't that colorful?
And the output of that controller, is it like a serial stream or something, or do you have a separate line for each knob and button on the controller?
I don't know. This guy, I think it's a proprietary protocol similar to SPI, but it's people have reverse engineered it. So there's libraries out there to go read it. So it's only like a 2 or 3 wire interface to the dongle there, which means that on all the buttons on this controller, it's really amazingly versatile because you got two directional joysticks, right? And then they each have like a push button there. You've got all these other buttons. These particular buttons also have pressure sensitive things underneath. And then these are buttons down here on both sides. So there's like, I don't know, there's a dozen or more buttons, but then you can, because the way the software is written and the way the controller is made, you can very easily select, say, when you hold this button and tap like, I have it so that when I hold the select button and do the triangle button, you know, see, oh, the start. When I hold the, sorry about all the jiggly. When I hold the start button and then push the triangle button together, on the fence, octopus man, okay. You'll see that the light will turn red because now it's going to start the one onboard routine. So that's out back.
Can you put a link in the chat to that?
Green again because it's done.
Can you add a link?
You can actually overload that and combine these different switches, and you can also detect, is the switch pressed? Did the switch change? Or did the switch just get pressed? Or did the switch just get released? So you can have like countless combinations of buttons just from this one controller and that simple interface on the other end. It's really, really nice.
Carl, can you put a link to that device in the chat?
Yes. Well, there's a couple links, but if you give me a minute while we keep chit chatting, I'll be happy to do that.
Oh, there he is.
So, anyhow, that's what I have to show. So, hopefully, with any luck next week, it should be easy to make the changes to the robot base. But then, if I have enough time left, I'll actually try and train a donkey cart for the first time after we talked ourselves into it a year and a half ago.
You'll at least be faster than the other project, where you took 2 years to get to, or 3 years to get to the base robot.
Yes, it was 3. I wasn't going to correct you, but yeah. No, I'm speeding up now. I'm catching up. You guys have been an amazing help to catch me up to what like high schoolers can do now. So that's good. For a washed out engineer turned PowerPoint manager. Okay. Well, that was it for my non-demo. Anyone else? And David, what I might do is just email that out instead of holding the chat open while you wait for me to search and find it.
That'd be fine. That's fine.
Okay. So with that, anything else we'd like to talk about this week?
Well, Ray's back.
He's in another dimension,
And he's moving a little bit too, even.
He's in a separate space timeline.
Yeah.
The time in his dimension doesn't really work. It's geologic time, I think.
It's either that or he's undersampled, or what is it? He's moving really
Smoke
fast
signals.
so that the relativity is in play.
I think.
Okay, guys. Well, with that, Ray, we're going to try and send some warm thoughts your way to your internet connection speed. Maybe we need to take, as they would say in Finland, take T-Mobile out behind the sauna, boom, boom. But there's our sound effects.
That's David.
And so ends our robotics visit virtual hideout.
No, that was Ray.
So, Carl,
All right.